Well, hello there. My name is Jay with CompuMatter and ServerMatter, and the purpose of this video is to teach my future self, and you in the process, what to do when a drive goes offline or in this case becomes unavailable. We're going to use a virtual machine to demonstrate this, but we do have a real-world situation. So behind me is one of our client's servers, and we have a drive right here that shows up as unavailable. It gives us a little information up here that there are sufficient replicas in the pool to continue functioning, but we need to replace the drive using zpool replace. Well, how exactly do we do that? Well, I'll tell you how we're going to do it. We've created a virtual machine in VirtualBox that mirrors our typical physical server environment. And that means 6 rated, ZFS rated drives that are not real drives. They're just carved out of the partitions of our regular Windows host operating system. But they've allowed us to install ZFS and Ubuntu on top of it and all that sort of thing. So we've got exactly the same scene. Let's introduce you to it. This is actually a virtual environment. This is the desktop login or greeter screen. This is that same machine from a SSH environment. Let's go ahead and get us to the bash user, and let's take a look at the status of our data pool in ZFS. And we see we have 5 drives, everything's online, looks good. We want to take one of those drives offline. In fact, we don't just want to take it offline, we want to knock it offline so that it's unavailable. To take it offline might be done programmatically, but instead we're going to shut down the VM, and then we're going to disconnect a drive in VirtualBox, which is going to be functionally the same thing as if a drive just completely failed on their own system, which it has for our client. Okay, so here's our 6 drives. We'll just pluck one out of the middle, number 4, and remove it. Now, we have also added and have in reserve drive number 10, which this is how that looked. We add a drive, we create, we give it a name. In that case, it was smvm smvirtual.biz. You can give it whatever name you want to, 10.vdi. And since all the other drives on that RAID array are 1 terabytes, we want to make sure that this is also the same or more. So we will leave it at 1 terabyte. And then we finished, and then we selected it, and that added it to our VM. So we've got that down here in reserve. We're going to swap that out for the missing one. Okay, start our VM up. Now, anytime you make a drive change in VirtualBox, I found that the boot time is significantly longer. There's our grub screen on the server, the virtual server. That is the bootloader for our servers and our virtual servers, but if we were to click behind that with the escape key, we can see what's happening. All right, we're to a desktop. Let's go ahead and log back in via SSH and take a look at the status. And we see we have a drive unavailable, which is exactly the same condition we have over here. And in this case, it lets us know what it was. Over here, it doesn't really say what it was, but we already know what it was because we have our information over here. Okay, so we've got number 4 missing. We're going to replace it with number 10. How do we know the UUID of number 10? It doesn't show up like smvm virtual 10VDI in the Linux environment. In fact, if we come over here and look at disk by ID, all it really gives us is ATA VirtualBox. It gives us a UUID here, but that UUID does not appear in the graphical user interface of VirtualBox. So here's how we're going to find it. We're going to go to the command line in VirtualBox, and we're going to type this command. vbox manage, show info, your VirtualBox name, and machine readable. Now machine readable is optional, but it makes things a little easier for you to read. And then we're going, this gives you all the information about that virtual machine. We are only interested in the drives, and of course we've got quite a few of them. We are in particular looking for number 10 VDI, which is right here, and this section gives it to us. And so we're going to pay attention, because this will help us isolate it, these first sets of characters, CBC5ED. CBC5ED. We'll come back over here, and we'll do that same thing, but we will grep for those characters. And so that's how you can find the UUID in VirtualBox and match it with what's in the Linux environment, although the entire string won't match. At least a piece of it will, and that'll get you where you need to be. So SDH is the one we're going to replace our missing drive with. In our particular case, we're using partitions. We're not using whole drives. And what we've got to do is create the partition on the new drive so that it matches the partition structure of the other RAID elements. And we'll do this like this. Let's take this drive, which will be the first in the array, and grep to find out what drive that is in the disk by ID. And we find out that is SDA. We'll run this command in parted dev SDA print to take a look at how that partition is structured. Now we need to create that partition structure on SDH. First we'll make label GPT. We'll then set our boundaries. And last but not least, make primary. Okay, now let's go ahead and take a look at parted SDH. And we see it is in fact the identical partition structure of SDA. So at this point we're ready to execute the final command, which is the replace command, and it looks like this. zpool replaced the actual pool's name, the old drive or partition in our case, and the new drive or partition in our case. So we'll take our old one, which will take our cue from this one, which tells us what it was. We did a grep for those numbers that we found in VirtualBox and found out it was SDH. So we'll grab that ATA and we'll just add a partition after it, just like the one before it. And hit enter, fire in the hole. And if all goes well, you'll get no reply, which has always felt a little anticlimactic, but that does appear to be the ZFS way. I've seen that in a number of cases. So let's clear all this text out of the way. Take a look at our pool status. I know it's in there somewhere. There we go. All right, and we have something that says replacing 3. Degraded, unavailable, resilvering, which is what we want to see. And here, resilver in progress. 7 gigs done, nearly 7% done. It's on its way. Let's give that another check. It's been a few minutes. Up to 21% done. Okay, all told that probably took maybe 10 minutes to resilver that 1 terabyte drive. Maybe a bit more than that. You see 80% there, and anyway, we're at 100%. I mean, it doesn't tell you 100%, it's just back to normal. Okay, so that went pretty smoothly. In the case of VirtualBox or a virtual environment, you can pluck a drive out of there at will, wait till it shows unavailable, and that works fine. But in the case of a physical server, you've actually got a real drive still plugged in that says unavailable. You may show up to their site and they don't have any other SATA ports or ports to plug in a new drive, and take over and replace. You might have to get rid of that unavailable drive before you can perform the action. So you've got to be able to identify by serial number or by chance what drive needs to come out before you can insert the new drive. So let's talk about our real client that we're going to have to visit in the next couple of days. Okay, so we're lucky enough in this case to be able to SSH into our client and see everything in advance. So the thing for us to do is A, buy a replacement drive, B, partition it in a way that matches the existing partition structure of one of their known good working ZFS members. I want to talk just a bit about the drive that you buy. A 1 terabyte drive is not a 1 terabyte drive is not a 1 terabyte drive. And what I find is I buy a 1 terabyte drive, I create the partition structure, and the partition is not large enough because some 1 terabyte drives use up a portion of their drive with the manufacturer's own instruction set that actually takes up a piece of the drive space. And so you've got to make sure that whatever the drive space you end up with, whatever the partition instruction you end up with is identical. And sometimes that takes trial and error. In this case, I found that I had to buy another team group drive. Otherwise, all the other ones, the Samsungs and the Western Digitals, and I went through a few of them, and I had to order them, and I had to get them here in order to find out, after testing, that the partitions weren't going to be large enough. I finally got a hold of a team group drive that actually had the serial number that matched the operating system because I tested for that. It was another requirement. You want to make sure that you test for those things before you show up. Otherwise, you're going to end up at the client's facility with a drive that doesn't have enough space, even though it's a 1 terabyte. And you can't partition it on the spot and make it work. And it's an emergency situation that you're going to have to walk away from until you get it right. We know that they only have 5 ports on that motherboard to replace drives with. So there's no question we have to pull the drive that says unavailable. Worse yet, in this particular rare instance, we know the team group drives that we're using, the serial numbers that they show here, the label on the drive itself does not match what the operating system comes up with. And so far, they're the only drive we know of where that's the case. So be aware that it can happen, however rare that it is. It was a mind blower for us when we ran into our first client. We never buy these drives, at least this particular type of team drive, as a result of that, because we need to make sure what's on the label matches what's on the operating system when you're using ZFS. But let's take this worst case scenario. We're looking at the 5 physical drives. We don't know which one is supposed to come off. We're going to have to use a disk roulette or Russian roulette, if you will, type of a formula to determine this. There's really no other way. So here's how we're going to do that. First of all, we've got to identify what device path this unavailable drive belongs to. In this case, we'll go LSL dev disk by ID, and we'll grep for a portion of the serial number that shows up in Linux. And that tells us it's SDB. That's all we've got to remember is it's SDB. Shut the system down, pull a drive. Once you've pulled a drive, rerun that same command. If nothing shows up, the drive you pulled is the drive you wanted gone. If it still shows up, plug that drive back in, pull another drive, and restart the process until the drive that you found in that disk by ID path doesn't show up. Now, that works in our case. We've got a couple of luxuries. One is the operating system is on its own mirror ZFS environment. So we've got 2 drives there, a root pool and a boot pool environment that this machine is going to boot no matter what. And we can play with these drives until we get it right. If I think about what would happen if we didn't have that and we had all the operating system, the data, everything, our entire world was on this 5 partition of 5 drives set, and let's go a step further than that. Let's say that we had no room for error, RAID Z1 environment, and we only had 1 drive failure possibility. That means if we unplug a second drive and this is our boot environment, it's not going to start at all. In a case like that, I would imagine the alternative is going to be to boot from an Ubuntu live environment, to install the ZFS related utilities, and to import your pool and operate it on an environment. It's obviously a lot more complex, but that gives you a way to go if it comes down to that. And that's it. That's how you deal with an unavailable or offline drive in ZFS. I hope you liked the video. If you'd like to be first in line and have a front row seat on videos like this in the future, be sure to click the subscribe button. Otherwise, give us a like, and thanks for watching. Bye-bye.